Alright, here's our second example. Find the domain of f of x equals 3x plus 4. So we've got a square root function. So the key here is we cannot take the square root or any even root of a negative number. It's not going to be defined in our real number system. And so whatever's under the radical, just take that entire expression and create an inequality. So we're going to say 3x plus 4 is greater than or equal to 0. So this could be equal to 0. The square root of 0 is 0, so that's okay. And it can be any positive number, it just can't be negative. Excuse me. So we just created a simple inequality. Well, let's solve it, not too bad. So let's subtract 4 over. So 3x greater than or equal to negative 4. Again, I just subtracted 4 from both sides. Divide that 3 over. So x is greater than or equal to negative 4/3. So that's inequality form. Again, let's just picture that. Want to really drive home interval notation that we worked with the other day. So greater than or equal, so it can be equal to that. So I'm going to color that in. And it can be anything to the right. So if I put that in interval notation, I'm going to start at negative 4/3, always left to right. And so it would be negative 4/3, comma, positive infinity. So there is the domain for that square root function. Now on a calculator, let me just show you. I graphed this, make that a little brighter. And I would encourage you to graph it on your own calculator and look at it. So a typical square root function looks like this, kind of half a parabola on its side. It just starts over here, that's negative 4/3 if we type that in our calculator. There's nothing over here to the left. Notice it flat out does not exist. So from negative 4/3 to the right up to positive infinity, you're going to see values for that. So that's how we deal with square root or even root functions.